Hello, my name is Chad Varney, and I'm an application engineer here at Ally PLM Solutions. I'd like to welcome you to another session of NX CAM Lunch Bytes. Today we're going to look at what's new in NX9 CAM. We have several of you on the line with us today, and you'll be in listen-only mode for the session. If you have any questions after the session, you can email those to me at chad.varney@allyplm.com. I want to remind you that we have all of our Lunch Bytes replays on our website, and you can check those out at www.allyplm.com. We also have a section where you can give us your suggestions for future Lunch Bytes topics. Today we're going to look at some of the new features in NX9 CAM. These aren't all of the new features, these are just some of them that we're going to cover today. We're going to look at face selection by edge boundary selection. We're going to look at Z-level arc, engage, retract options. We'll also look at the new divide by holder dialog. We'll also look at show thickness by color options. We're also going to take a look at cut region control. And then we're also going to take a look at groove milling, which is a new operation in NX9. And we will also look at paste operation with reference. All right, so we'll get started. The first part we're going to look at is just a small cavity mold. What I want to do first is just cut this inner area. All right, I don't want to cut anything on the outside. I just want to cut the inner cavity shape. All right, to do that, in previous releases, we would have to select faces, or maybe do a window select to select that area. But in NX9, there's an enhancement where we can actually just pick one face and then a boundary around that. So I'm going to go ahead and create an operation. I'm going to do a Z-level profile operation. Notice I do have three different tools here: a short diameter 4 ball mill, a medium diameter 4 ball mill, and a long diameter 4 ball mill. We're going to divide those up here in just a minute. For now, I'm just going to use the short diameter 4 ball mill. Alright, so I'm going to go ahead and do specify cut area. And again, before we would have to pick all these faces or maybe do a window select, but there's actually another option now called edge bounded region. So all I really need to do is select a seed face, any of these seed faces in the middle here. So any of these, and then a specify bounding edges. So I'll specify the bounding edges, right, and then preview that, and then it actually selects all of these surfaces for me just by picking one face and the bounding edges. So a very nice way to kind of contain your cut regions and pick cut regions. And I'll go ahead and generate this operation. I'm going to go ahead and just leave the default settings except for the step down. Alright, and what we'll see is we just have normal arc in moves like that we're used to seeing. These are just arc in moves that are horizontal. Okay, we've had other options in other toolpaths, but for Z-level profile, we've only had this style of arc-in move. Well, we now have in NX9, we have a couple different options for arc moves. Notice we just have regular arc, and then we also have parallel to tool axis, and as you can see in the picture there, it runs parallel to the tool axis. We also have normal to tool axis. And then we also have normal to part. I really like this one because it's going to create our arc moves normal to the part geometry. So let's take a look at that one. I'm going to change it to normal to part and then generate. So as you can see now, these arc moves are normal to the part surface. That can come in pretty handy if you're trying to get in a tight area where a normal arc-in move wouldn't have enough room to get in there. So these are actually normal to the part surface. So it's definitely a nice way to do that, and probably going to give you a better finish as well. Alright, so now that we have the toolpath created, as I mentioned before, I'd like to break this up into 3 different toolpaths. I have a short tool, a medium length tool, and then a long tool. So to divide that, if you take a look at this is what our divide by holder option looked like in 8.5. So let's take a look at what it looks like now in 9. So I'm going to do divide toolpath by holder. Obviously we have a much more detailed dialog. So what I'm going to do is I'm going to take the medium tool and add it to the list, and then the long tool and add it to the list. Alright, and now I'm going to divide the toolpath using these 2 tools. I want to divide at the transfer. Basically, I want the toolpath to divide on a cut level and not in the middle of let's say an actual toolpath. So I'm going to change that to transfer, and then I'm going to do 1 millimeter of clearance instead of 3 millimeters of clearance. Go ahead and generate that. And notice what we have. We have 3 different toolpaths, and you'll see here that I have the first toolpath goes down to what the first tool could reach. Then I have the second one, which is the medium length tool, so it only cuts the areas that the medium length tool can reach. And then down at the very bottom with the longer tool, I also have a different toolpath. So definitely a big advantage there to be able to divide your toolpaths by holder. Okay, the next part that we're going to look at is this contoured part. I've got a cavity mill operation, a rest milling operation, a flow cut operation, and then a Z-level operation. Notice we haven't cut the shallow areas yet. We'll do that here in just a little bit. But what I first want to do is take a look at the show thickness by color option. I'm going to go ahead and go to the rest milling operation and do a verify, and I'll speed this up a little bit, and then we'll verify this through. So it's going to start with the rest milling operation, and then it's going to show the rest milling operation. We already did the cavity mill, and also you'll notice that the previous operation is blue, and then we have the different color operation that's currently running. Okay, so now what we're going to do is take a look at show thickness by color. Previously in NX 8.5, this is the show thickness by color dialog. There's not a whole lot of options here. We could specify the point and then maybe specify the blend settings, but you'll see in 9 there's a lot more options available. So we'll go ahead and go into show thickness by color. Okay, and what we have here is we basically have the same thing that we had available by being able to specify a point. So we can pick a point anywhere on here and specify how much material is left in any particular area of the part. Right? And then we also have a number of ranges. We can specify a number of ranges. So now it's set to 8, so I'm going to change this down to maybe 6. So we have a different number of ranges. Also, minimum and maximum limits. Notice it's set to automatic right now. I'm going from 0 to basically 1.3. So for example, we can change that to user defined, and maybe we want to show anything that's larger than maybe 0.5 millimeter. So I'm just going to type in 0.5 in the lower limit, and then I'm going to go ahead and leave the upper limit the way it is to about 1.3 and apply that. So now what it's doing is it's showing everything in blue that's less than 0.5 stock, and then anything from 0.5 to 1.3 is showing in the different colors that you see here. So this is definitely a nice way to analyze your part, so you can know how much material has been removed and then how much material that you're going to need to remove later on in future operations. So this is definitely a nice enhancement, being able to visualize this a lot better before you get out onto the machine. Alright, so the next thing I want to do is I'm going to create operations to cut these non-steep areas. I want to cut the top of this boss shape here, and then the 5 angled shapes here on this hub, and then also these flat areas down here at the bottom. Okay, so again, I've got a Z-level profile already done, but we don't have anything that cuts these areas that I just mentioned. Right, and then we're going to also take a look, while we cut those areas, we're going to take a look at the cut region control that's new in NX9. So I'm going to go ahead and create an operation. I'm going to use area contour area, and I do have a short diameter 10 ball cutter and then a long diameter 10 ball cutter that I want to use for these cut areas. So for now I'm going to use the short diameter 10 ball. Okay, and I'm going to go ahead and go into the drive method settings. Notice I have options to do non-steep, directional steep, steep, and non-steep. That's what I want for now, is steep and non-steep. I'm going to break that up at 40 degrees. Also notice that we do have the option to create separate regions for flat areas. For example, if you are going to cut the flat areas, maybe with an end mill or a flat cutter, you can separate those as well. So that's definitely a nice option there. But for demonstration purposes, I'm going to do steep and non-steep, broken up into 40 degrees. For this first cut, I want to do a zigzag radial pattern. I'm going to specify the center, that's good. And then I'm just going to do a constant step over of 0.5 millimeter. Alright, so what we'll notice, I'm going to go ahead and go into cut regions. This is new in NX9, cut regions. Alright, and I'm going to go ahead and generate our cut regions for now. Alright, what you notice is it breaks up the steep and non-steep areas in different colors, and then it also has those listed here. One other thing I want to point out is we have a collision column, okay, and this is unknown status right now because I don't have collision checking turned on. So what I want to do is go ahead and turn on collision checking, and then it'll actually break these cut regions down even further based on where the tool or holder collides. So I'm just going to go into my cutting moves, turn on check tool and holder, and now go into cut regions and generate a cut region list. So again, now this is going to actually collision check the tool and the holder with the part and then generate our cut regions. The previous way that we had to do this was basically in verification you could check your collisions with your holder and your tool, and then it would show you areas that would collide and areas that were safe. Now we're actually kind of doing that in the operation, and we can kind of see what's going to happen before we actually generate the operation. So let's take a look. So now we have all of our cut regions listed here. They're also shown out here in the graphics window. We have this nice list here. The list can be shown in basically in different categories. So you can see that we have a type, steep or non-steep, and it shows the symbol there. And also what's really nice is we have a red and a green now instead of that yellow. So we have a fully colliding symbol and a non-colliding symbol. Okay, so we know what's colliding and what isn't. All right, so what I was saying earlier is I want to just cut this top of the hub, these 5 angled shapes, and then this flat down here. So with the short tool, it looks to me like I'm not able to reach down in this bottom area. So I'm going to have to use the long tool to reach down in this bottom area. Also, I don't need to cut these steep areas because I've already cut them with a previous operation. So I'm going to make sure that I have all of my steep areas at the top of the list so I can filter this by the type, steep versus non-steep. So now I have all of my steep areas at the top of the list, and I can actually take this and delete them out of the list. So now all of my steep areas are removed from the list. Also, another thing we can do is if you notice these kind of smaller areas, this is kind of a big tool to be cutting a real small area like this. Probably in this case we would go back in maybe with a smaller tool to cut these radius shapes. So we really don't need this tiny little area here. So we can delete those as well. I can actually delete those either by picking them over here in the list or out in the graphics window. I'm going to go ahead and select all these in the graphics window and delete those as well. So now I've got this narrowed down to basically the areas that I want to cut. However, like I mentioned before, you can see these areas in red. If I highlight them over here, for example here, notice that this area is an area that I can't reach with this shorter tool. I'm going to need to use a longer tool there. But it did go ahead and break up this cut area between the area that does not collide and the area that does collide. So you can get a really good idea of how that works. Also, I want to make a mention here if you're doing like repair work and things like that. For example, maybe you only have to cut the top of maybe this angled shape and this one. You only have to cut the top of 2 of them for some kind of repair. You can delete all of the rest of the other cut areas and only leave these 2 cut areas. So what I want to do now is, again, I want to cut these with the short tool and then this with the long tool. Well, I don't really want to break these up. If I'm going to do these later with a longer tool, I want this cut region all to be connected. Well, you can actually merge these 2 cut regions. So what I'm going to do is select this cut region, and then I can actually merge that cut region with this cut region, and notice it combines the cut region. So it's a really nice tool to use to see exactly what areas are colliding and what areas aren't, but you can actually go back and merge cut areas if you need to. So that's what I'm going to do. I'm going to go through here and merge each of these cut areas. Alright, and the last one here. Okay, that looks good. So now you can see the symbol changes to partially colliding, basically meaning that some of this cut area will collide and some of it won't. So again, we're going to switch this to the long tool, so that's fine. So now I'm going to filter this by areas that are safe or non-colliding, and then areas that are colliding. Right, and then what I'm going to do is go ahead and turn off the areas that do collide. And then I'm going to go ahead and create the operation with just the areas that we're able to reach with that short tool. Okay, so that looks good. Now what I can do is I can actually copy this toolpath, paste inside here, and then I can go back in, or actually let me go ahead and change our drive method. Let's change our drive method. We want it for this bottom area. Maybe we don't need as good of a finish, or we want a different type of finish. So I'm going to change this to follow periphery, and maybe I'm going to change this to a millimeter step over. And then I'm going to actually change this to the long tool. All right, and now I'm going to go into cut regions, and I am going to import the cut regions from the previous operation. Notice these are all of the cut areas that we had left over from the other operation. That's exactly what I want, so I'll hit OK there, and then generate that. So now I have only the areas that did not get cut in the previous operation. So again, the new cut regions option is pretty useful. Alright, that's all I have with that part. So let's go to the next part, and we'll take a look at the new groove milling operation. Alright, the part that I have here, as you can see, has a slot shape on the side here, and then another slot shape here as well. You could do that previously in other versions, but now we have a specific operation that will cut grooves and like T-slot type shapes. So I'm going to go ahead and create an operation, and notice we have a groove milling operation now. I'm going to select the T-cutter, and notice we have specify groove geometry. So all I need to do is simply pick the face of the groove, and notice we have an in-process workpiece option. It is going to look at the in-process workpiece and determine the cut area for us. Notice it also determines the length, width, and depth for us as well. These are inherited from the geometry that I picked. You can override these as well. For example, maybe you don't want it quite as wide. You want it maybe 15 wide instead of 16, or you want to go a little bit deeper. You can manually change these as well. So I'm going to go ahead and accept this. And I've got number of passes set to 2. That should be fine. I'm going to need to do 2 passes. And then let's take a look at cutting parameters. There's some new, cut levels. There's some new options here. Notice we have level sequencing. So we have an option that we can start at the ceiling, basically the top, and then work our way down towards the bottom to the floor. Or we can go from the floor, which is the bottom, and work our way to the ceiling, which is the top. We can start in the center and then go to the ceiling and then the floor. Start at the center and then go to the floor and then the ceiling. And then we can actually alternate, going to the ceiling first and then alternate back and forth. Or go to the floor first and alternate back and forth. Okay, so a lot of nice options there. Okay, I'll go ahead and generate this, and we'll go ahead and take a look. Alright, so what we get is 2 passes, and again, this is based on our 3D IPW, so our in-process workpiece. So for example, if this slot had already maybe been roughed in, it would not take all of these extra cut moves. It would know that that slot's been roughed in and know that it just needs to do a finish cut based on the in-process workpiece. Alright, now we're going to go ahead and create an operation for this slot here. As you can see, this breaks out into this open area, but that's still no problem. We'll go ahead and create an operation, use the same groove milling operation. and I'll simply just pick the face, and notice it knows to go ahead and extend that out, especially since we are using the IPW. It knows that that's not been cut yet. And then we'll go ahead and generate that. And there you have it. So definitely a nice way to do slots and grooves by the new groove milling operation. All right, the last thing that I want to look at today is if you have an assembly, maybe you have multiple parts in an assembly, and if these parts are identical, we have the option available now to paste with reference. Before, we used to have to just paste an operation, and then it was really not associative. We also had the option to maybe instance or copy, multiple operations, but again, that was not associative. So, as an example, what we used to do would be just copy, all right, from the first workpiece, which is here, and then we could paste it into the second workpiece. So I could do a paste inside, all right, and then I'd have to actually generate this operation. And then, let's say, for example, maybe I needed to make a change into this operation. Let's say I had to change maybe the step down. So I changed the step down in this one, maybe to 15, generate. Okay, so now I have my step down changed, but in this one, I still have the same step down. So now I got to go into this one. And as you can imagine, that could be time consuming if you have multiple tool paths. All right, and you get maybe out to the machine, you realize, you know what, I need to, change a few settings in these. You're going to have to change them all here and then all here again. Okay, so let me go ahead and delete this one. But now we have the option to copy this and then paste inside with reference. All right, so now I have the exact same operation from here, the first workpiece, as I do with the second workpiece. And notice when I highlight the second operation, the copied operation, notice that the original operation turns red, showing that it's basically dependent or a child of the original operation. So now when I go ahead and make a change to the original operation, let's say I change this step down to 2 millimeters instead of 15, generate that, and notice the second operation, since it was pasted with reference, it also changes. So you don't have to make the changes multiple times if you paste with reference. So as you can imagine, that would be really handy if you got a large assembly or multiple parts that you're doing all in one setup. So definitely going to be a big time saver there. Alright, well that's all I have for this session of Lunch Bytes. Hopefully you were able to get a better idea of some of the new features in NX9 CAM. If you've got any questions about today's Lunch Bytes, please email those to me at chad.varney@allyplm.com. Also want to encourage you to go to our website at www.allyplm.com and check out our current training options. We offer a 1-week Essentials for NX Designers class. We also offer a 1-week NX CAM Fundamentals class, and then we offer a 2-day NX Turning class as well. These are available here at our Cincinnati location and then also online. You may have noticed that the user interface changed in NX9 as well. We do have 2 Lunch Bytes coming up on April 17th and May 22nd. These are What's New in CAD NX9 Part 1 and 2. Those will be discussing the user interface as well and some of the user interface changes and also some customization options as well. So be sure to tune in for those. I want to thank you for joining us. Hope you have a great day.